Hey guys, welcome back. I want to go ahead and go over some more examples in preparation for your AP exam. Now this time we're going to go ahead and start talking about graph analysis. There are various different types of problems that you guys might see on the AP exam. One of them is they're going to give you a graph. You're going to have to analyze it based on what they give you. And a lot of times they give you a graph which is like a piecewise function. You're gonna have to analyze it. One of them is a derivative, one of it's the function. So let's go ahead and look at this one. This is from 2011. Okay, and so let's just see what we can pick from it, and just if we can start looking at some patterns of what they're asking. Okay, so let's start with the question here. The continuous function f is defined on the interval from -4 to 3. The graph of f consists of two quarter circles. You see that? That's important. That's important right there. And one line segment as shown in the figure above. Okay. Let g of x represent this integral. Okay. So now, remember, part A is the easy part. Okay. Part A is the easy part. Find g of -3. Find g prime of x and evaluate g prime of -3. Okay, so first part, what do I do? Well, I need g of 3. Well, they give me g of x represented by this integral. So all I have to do is just plug in 3 or -3. So is g of -3 is 2 times -3 plus the integral from 0 to -3 of f of t dt. Okay, great. So now 2 times -3 is -6, and that's the easy part. Well, then how do I figure out this guy? Now remember, this is the graph of f. Well, how do you integrate when they give you a graph? Remember, the integral is the area underneath the curve. So what we have to do, guys, is we have to find the area between 0 and -3 underneath this curve. So we're talking about from here to here. Now there's one little thing though, you're gonna have to be careful, because remember, the limits of integration should go from lower to higher. Now, the fact that I go from 0 to negative, that means I'm going backwards. That means the area is going to be negative. Or actually, I should say the integral is going to be negative. So what I'm going to do, though, is I'm going to go ahead and reverse this integral right here, okay? Instead of being positive, okay, I'm going to make it a negative, and I'm going to reverse the limits of integration. -3 to 0 of f of t dt. Okay, and I can do that, and I just do that just for my sake, just because I like going from left to right. So from -3 to 0, from -3 all the way to 0, I gotta find this area right here, all of this guy right here, this area underneath here, right here. Okay, guys, that's what I gotta figure out. Well, and that's why this is important. It says it's 2 quarter circles. So the area of a circle is pi r squared. Okay, pi r squared, but because it's a quarter circle, I'm gonna be divided by 4. So what's the area? I'm sorry, what's the radius? This is the center, 1, 2, 3. So 3 squared. Okay, what's that gonna give me? Well, that's gonna give me -6 minus 9 pi over 4, and that's it. You don't simplify. You don't try to do anything else with it. You just leave it as is. Okay, so that's the first part. Then it asked me to find g prime of x, okay, and evaluate it at g prime of -3. So that's two things. Notice here, you need to find g prime of x first. So g prime of x, that means I have to take the derivative of my g of x. So what's my derivative of 2x? Is 2. Plus, what happens when I take the derivative of the integral? That's right, it cancels out or it simplifies out. So what am I left with? All you gotta do is, remember, plug in your x in here. So you're left with f of x. Okay, no dx, no nothing like that. Just plug this guy in right here. Okay, part of the fundamental theorem of calculus. The derivative of the integral simplifies out, but you're replacing this guy here. And I'm pretty sure your teachers have gone over that. Okay, that's it. Now what do I have to do? I have to go ahead and plug in my -3. Okay, so I'm going to get 2 plus, plug in that -3, f of -3. Okay, so what is f of -3? See, this is your graph of f. So what do you do? Now, When x equals -3, 1, 2, what's my y value? The y value is 0. There it is. So g prime of -3 is equal to 2. All right, guys? And that's it. Okay, so not too difficult. You're just plugging in stuff and understanding and interpreting. Guys, that's 3 points right there. That's 3 points. If you only get that one, that's 33%. Okay, and 3 points out of 9, that's 1/3. That's, you're on your way to a 3. Okay. All right, part B. Determine the x-coordinate of the point at which g has an absolute, look at that, maximum on the interval. Now, that's important. Hopefully, it's starting to kind of come together. Okay, remember, in the past videos, we've talked about that with particle motion and even the rate accumulation, max, min. Those are fundamental to calculus. How do you find the maximum and the minimum? Okay, you're gonna take the derivative. All right, you can have your function. You can take the derivative. All right, whatever it is, set it equal to 0. Find your critical points, and you're gonna do the number line. Remember that process? Yes, I mean, and your teacher maybe explained it differently, but that's essentially what we're doing to find the maximum. Okay, so what do I have to do? Okay, it says determine the x-coordinate of the point at which g has an absolute maximum. Okay, they give me a representation for g. Okay, so what do I have to do? I have to find g prime of x, set it equal to 0. So what's g prime of x? Hey, I already found it right here. Okay, so that's 2 plus f of x. Set that equal to 0. Okay, so I have 0 equals 2 plus f of x. All right, great. Now what do I do? Well, I keep solving it. All right, where does f of x equal to -2? Okay, now understand what this is telling you. F of x, remember, that's your y value. Okay, and that's your y value. Where is f of x equal to -2? Okay, you go to your graph of f. Your y values are -2 right here. What's the x coordinate? You go here, somewhere right here, and the only thing I don't like about this is sometimes you can't really tell, but you should be able to tell. It looks like it's 2.5. Yeah, it's 2.5. So it's 5/2. Okay. So my critical point is what? X equals 5/2 or 2.5. Okay, that's your critical point. Okay, so took my derivative, set it equal to 0. My critical point is x equals 2.5. Now what do I do? To verify that it's maximum, I have to do the number line. I have to do a number line. So we can go ahead and do it. Yeah, we'll do it right here. Okay, so here's 2.5. Well, where do I plug it into? Remember, you're going to plug it into the derivative. Yeah. Okay. Because you want to see if it's increasing, decreasing. So to the left of 2.5, what do we have? Well, let's pick 0. All right. Put 0 here, right? Okay. Put 0 here, right? What's f of 0? Okay, so when x equals 0, what's my y value? My y value is 3. So then you have 2 plus 3. 2 plus 3 is 5. That is a positive. So that means it's going up before 2.5. Okay, let's pick a number after 2.5. Let's pick 3. Okay, so we put 3 here. All right. So 2 plus f of 3. All right. 2 plus f of 3. What's f of 3? When x equals 3, what's my y value? 1, 2, 3. What's the y value when x equals 3? Boom, it is -3. So what is 2 plus -3? 2 plus -3, that is -1. So that's a negative. Boom. Okay. And there it is. So you would go ahead and say G has an absolute maximum at x equals 2.5. Why? Okay. And you can just say because g prime of x is positive, okay, before, and then g prime of x is negative afterwards. Okay, but if you show this representation, It's fine as well. Or you can just say changes from positive to negative, and you're fine. Because remember, these are human beings, okay? And if I see this, okay, oh well, they know what they're talking about. All right. All you got to do is tell me that there's a maximum and a minimum. All right. You show them there's positive, there's negative, and you're set. All right, guys. Because remember, they want you guys to do well. They want you to pass, but you have to demonstrate. And not all of us are verbal. We're visual. So this, perfectly acceptable. All right, part C. It says find all values of x on the interval for which the graph of g has a point of inflection. Notice that. Think about this. Remember, point of inflection. What is that? That's the second derivative. Second derivative. Okay? That's the second derivative. So we're going to go ahead and take our second derivative. Okay? So we already found g prime of x. Cool. So we know g prime of x is 2 plus f of x. So what's our double prime? What's our second derivative? Well, the derivative of 2 is 0, and then the derivative of f is f prime of x. There it is. Okay. Now what do I do? Okay. I have to figure out, okay, find the values where g has a point of inflection. Well, how do I figure that out? Take the second derivative, set it equal to what? 0. That's right. Okay, so we're going to take our second derivative, set it equal to 0, and find those critical points. Okay. Now, you're going to have to look at your graph of f. Okay. Where is f prime of x? 0. 0. Okay. Where does it have a horizontal tangent? And the only place that it has a horizontal tangent, if you notice, is right here. Horizontal tangent. You see? Right here is a horizontal tangent. Okay. Now be careful. This guy here, that's a vertical tangent. Okay. But right here, that's a horizontal tangent. And what's that x value right here? At x equals 0. Okay. So you would say at x equals 0, f prime of x is equal to 0. Okay. Therefore, okay. F has point of inflection at x equals 0. Okay. And that's it, guys. That's it. But notice, hopefully it just makes sense. Took the second derivative, set it equal to 0. All right, what does that mean? The second derivative, the f prime of x equal to 0. So I look at this. Now you're looking at the graph. What's the slope? See, this slope is negative, right? It's going down. You just look at it. It's going down. Where it says it's horizontal. It's tangent. Okay. Last one, part D. Okay. It says find the average rate of change. Interesting. Important there. Okay. Of f, of this guy, on the interval between -4 and 3. There is no point C between -4 and 3 for which f prime of c is equal to the average rate of change. That's kind of contradictory, isn't it? First they ask us to find the average rate of change, and then they say there's no point C on the open interval for which the derivative f prime of c is equal to the average rate of change. And it says explain why this statement does not contradict the mean value theorem. All right, so let's just kind of break it down to the first sentence. It says find the average rate of change. Okay, now if you think about it carefully, as soon as you see average rate of change, okay, thinking derivative, rate of change, that's a derivative. Now of f, right, you look at your graph from where to where? From -4 to 3. How do I find my derivative? Think of your slope from here to here. Think about it. So what you're going to do, guys, take your ruler. Boom, guys. All you got to do is find the slope of these 2 points right here. That's what you have to do. You're going to have to find the slope of these 2 points right here. Well, how do you do that? Basic algebra 1, y2 minus y1. So your slope, okay, guys, would be -3 minus -1 over 3 minus -4. And now be careful because they'll throw in those negatives, okay? So -3 plus 1 is -2. 3 plus 4 is 7. That's the average rate of change of this guy. That's the average rate of change. Now, the second part, it says, explain why this statement does not contradict the mean value theorem. Okay. Now, why doesn't it contradict the mean value theorem? Because the mean value theorem says that in order for us to be able to use the mean value theorem, the graph has to be differentiable along each point. So from here to here, the graph has to be differentiable. Okay. Now, continuous and differentiable, actually. Now, it's continuous, but see, that's not differentiable here because we have a cusp, and it's not differentiable here because we have a vertical tangent. That's why we can't use the mean value theorem, okay? And that's what you would tell them. All right, guys? So let's go ahead and do 2012 and see if we can pick up some of the similarities that they asked in 2011. So here's another FRQ, another graph, and what do you notice? What do you notice? Line segments and circles. A lot of times they do that, okay? And then we'll be doing 2013, 14, 15, as many as we can till we get to 2019. And then just so you guys can see what they're looking for, what they're asking. All right, let f be the continuous function from -4 to 3, whose graph is consistent with 3 line segments and a semicircle centered at the origin given above. Actually, it's right here. Let g be the function given by g of x from 1 to x of f of t dt. Part A, it says, find the values of g of 2 and g of -2. All right. Okay. So what do? Part A is the simple part. What's g of 2? Plug in the 2, right? Plug in the 2 right there. So now we got the integral from 1 to 2 of f of t dt. That's it. So now what do I have to do? I have to do the integral. Well, how do I do that? What do they give me? A graph. What's the integral? Area underneath the graph. So from 1 to 2, from 1, x equals 1 to x equals 2 right here. Okay, so I need to find the area of this guy. Now be careful now. Okay. This is 1, and this looks like it's 1/2, right? Because this is 1. So it's 1 times 1/2. You're finding this guy. Okay. So it's 1, actually 1 times 1/2, and actually -1/2. The area is going to be -1/2. Remember, the area underneath the curve is between the x-axis and the curve. So as you see how it's below the x-axis, it's going to be, the area is going to be negative. So just keep that in mind, okay? So the answer is -1/2. No. Be careful. What's the area of a triangle? Base times height, and then you take half of that, right? And you take half of that. So the answer is actually -1/4. So you really have to be careful, because you see a triangle, oh, base times height, you do it so fast and then you forget. All right? So just be careful. Now, g of -2. How do we find g of -2? Well, we do the same thing. Okay, we do the integral from 1 to -2 of f of t dt. And what do you notice here? Well, you notice from 1 to -2. Here's 1, -2 is back here. It's going backwards, isn't it? It's similar to 2011, isn't it? So what I'm going to do is I'm going to reverse the limits of integration. So I know it's going to be negative. So it goes from -2 to 1, f of t dt. All right, so now I'm going to go from -2 all the way to 1. And then so right here, here's my triangle. So I got to find that area and this semicircle right here, all of this. Now remember, it's the area underneath the curve. So that's a negative. I'm going to leave it like that. So this distance is a triangle, right? So what is this? 1 and then times 3. 1 times 3 is 3. Half of 3 is 1.5. I'll just leave it as 3/2. That's positive. Why? Because it's above the x-axis. Now, what about this semicircle? You see how it's below the x-axis? It's going to be negative. So what's this? Pi r squared. Correct. Pi r squared. But because it's a half circle, we're going to divide by 2. What's the radius? The radius is 1. There it is. Okay. So you're going to get negative. And then 3/2 minus 1 squared is 1, pi over 2. Okay. And I would say you can actually leave it like that. That's perfectly acceptable. If you want to distribute the negative, go for it. But I'm just going to go ahead and leave it like that because that's acceptable to the graders. All right, they're testing our calculus, not our arithmetic. All right, let's go to the second part. G prime, okay, G prime of 3, okay? So, again, they gave us G of x, don't they? All right, let's take the derivative. G of x, what's the derivative? Let's do G prime. Let's do the derivative first here, this guy. So what's the derivative of this guy? The derivative cancels out the integral, and we're just left with plugging in the x. All right, so G prime of x equals f of x. There it is. So now I just plug in my -3. G prime of -3 is equal to f of -3. I can do this. Now I got to use my graph. So when x equals -3 and -3, 1, 2, what's my y value? So I go up here. It looks like it is 2. Yeah, 2. So the answer would be positive 2. So when x equals -3, the y value is 2. Okay. Now I have to figure out g double prime of -3. Okay. So I got to take here. I know g prime of x is f of x. So the second derivative is I take the derivative of f of x. That means f prime of x. Cool. All right. So now g double prime of what? -3 equals f prime of -3. Well, how the heck am I going to go ahead and do that given a graph? Now remember, they give you a graph, right? So at x equals -3, where's -3 at? It's over here. Well, how am I going to figure out the slope, the derivative? That's right. You're actually going to take the physical. Look at the line. The physical, you're going to take the slope. You're going to find the slope between these 2 points. That's what you're going to do to get the second derivative. So y2 minus y1, so f of b minus f of a. So you're going to do 3 minus 1. Okay, going back to algebra 1, right? 3 minus 1, and then -2 minus -4. Okay, and we should get a positive slope. So 3 minus 1 is 2, and then -2 plus 4 is, what is that? 2. So your slope is 1. Okay, so second derivative. But you see how we're doing that? We're using the graph when we're actually looking at it and figuring out the steepness of that line. Okay, and that's part A and that's part B. And guys, if you get those two, that's 5 points already right there. You're way on your way to a 4 and a 5. Okay, actually, I'm sorry, that's 4 points. Yeah, but you're on your way. You're on your way to a 4 and a 5. Okay, that's part A and part B. So let's do part C now. Okay, find the x-coordinate of each point at which the graph of G has a horizontal tangent line. Okay, so I know tangent line means derivative. Horizontal, okay, I know what that is. So I want the derivative of where it's horizontal, okay, of what? G. So guys, I want to know where G prime of x is equal to 0. And look at what they're asking. For each of these points, determine whether G has a minimum, a maximum, neither a minimum or a maximum. So what are they asking us? First derivative, set it equal to 0, find your critical points, number line. That's what they're asking. So find the x-coordinate for each point at which the graph of G has a horizontal tangent line. G, okay, boom, here's G, all right. Tangent line, derivative, first derivative, set it equal to 0 because it's horizontal. All right, but you know what? I already found my first derivative, didn't I? G prime of x. So set it equal to 0. So that means f of x is equal to 0. Well, you look at the graph. Where is f of x equal to 0? Remember, f of x represents the y values. Where are the y values 0? The y values are 0 right here, there, and right there. Okay, so you have x equals 1 and x equals, -1. All right, those are your critical points. Okay, those are your critical points. And now what do? Well, you're going to go ahead and do a number line. Okay, and I would just do a number line if you're more comfortable with that, whatever you did in your class. Okay, so now we're going to be doing f of, right, the derivative, g prime of x. Or if you want to put f of x, it's the same thing, okay? So look at what's to the left. To the left here, all right, See? See, all of these are a bunch of slopes, okay, points. The points represent the slopes. They're all slopes that are connected. All of these are positive slopes. All of these are positive slopes. All of these here are negative slopes. Connected. That's what they are. So to the left of -1, it's all positive. Okay, between -1 and z and 1, it's what? They're all negative. And then between 1 and 3, they're still all negative. You see that? So it goes up, down, and then down. So right here you have a max. There you go. There's a max at x equals -1. Why? Because the sign changes from positive to negative. Okay? Or the slopes change from positive to negative. And what about x equals 1? Well, it's neither a maximum nor a minimum. That's what you would do. All right, guys? So hopefully you're able to see that. Part D. For -3 to 3, find all values of x for which the graph of g has a what? Point of inflection. What's point of inflection? Second derivative. Explain your reasoning. Okay. The graph of g. Okay, the graph of g. So we need to find the second derivative. Okay. Did we find the second derivative? Yes, we did already, didn't we? Over here in part B. Second derivative, that means f prime of x. And we talked about that. Well, how am I going to find f prime of x if they give me just the graph of f? Well, you're going to look at what? You're going to look at the slopes of these line segments. So look at it. From here to here, positive slope, right? Isn't this line going up? Positive. And then from -2 all the way down over here, it's what? Negative slope. And then here what? Positive slope. And then here what? Negative slope. So from here to here is what? Positive slope. That means it's concave up. Okay. From -2 to 0, it's going to be concave down. From 0 all the way to 1, it's concave up. And then from 1 to, what is that? 3 is concave down. You see how it's changing? Positive, negative, and then the slope is positive, slope is negative all the way down here, and then it's positive, and then it's negative. So guys, you have a point of inflection here, and then here, and then here. All right, guys? So your points of inflection, okay, are at x equals -1, x equals 0, x equals +1. Why? Okay, you would just say because f, okay, changes signs, okay, and then you just say from positive to negative. And you know what? I would encourage you, write this down, you know, plus, minus, and they're able to see what you're trying to demonstrate. And that should be very good enough of an explanation, okay, because they want to see it. And remember, some of us are more visual than others. So hopefully, guys, that helps out. I'll go ahead and continue working on the next few years so you guys can get prepared. All right, guys, see you guys next time.